Greetings. I'm Mr. French, and I'm coming to you from my classroom in Mount Pleasant, Utah. And this is topic 4.2, straight line motion connecting position, velocity, and acceleration from the AP Calculus AP classroom curriculum. Well, let's look at how position, velocity, and acceleration are all tied together. Well, position, we will use x of t to measure position along an x-axis. And as that position changes, we'll look at its velocity, which is v of t in most cases, and then acceleration, a of t. Well, velocity is the rate of change of position. As my position changes as time goes by, we get a change in position, and changes are derivatives. So velocity is the derivative of position. Units of position could be feet. Um, Units of velocity then would be feet per second, or a unit measurement versus a time measurement, a distance measurement versus a time measurement. Acceleration is going to discuss how the rate of change of velocity works, which means that acceleration is the derivative of velocity and the second derivative of position. And here the units would be feet per second, or feet per second squared. Normal convention, if we're talking about straight line motion, moving to the right will be a positive velocity, and moving to the left will be a negative velocity. Zero velocity would mean that our particle is at rest. Let's take a look at speed, another concept that's fairly important when we discuss motion of a particle. Here I have some examples of a particle's velocity, v1 and v2. So these are velocities. And I'm going to look at what happens across time. So if my first velocity was 20 feet per second, and my second velocity was 25 feet per second, well, my change in velocity was a positive 5 feet per second. If my initial velocity was 20 feet per second and my secondary velocity was 15 feet per second, well, then my change in velocity was negative 5 feet per second. If, on the other hand, I was moving to the left initially at negative 20 feet per second, and then my second velocity is negative 25 feet per second, well, then my change in velocity is again negative 5 feet per second. I went from negative 20 to negative 25. Now, if I started at negative 20 feet per second, moving to the left, and then the second time I looked at my velocity, it was negative 15 feet per second. Well, then my velocity actually went up positive 5 feet per second. So in each of these instances, what we want to see is whether we are speeding up or slowing down, where speed is defined as the absolute value of velocity. It's a scalar quantity with no direction. Well, if I think about the absolute value of my velocity, I went from an absolute value of 20 to an absolute value of 25. My speed increased. So I'm speeding up. In my second example, I went from an absolute value of 20 to an absolute value of 15, which means I slowed down. Here, when I've got a negative velocity to start with, my absolute value of negative 20 is 20, and my absolute value of negative 25 is 25. So my speed increased from 20 to 25. I'm speeding up. And in my final example, with an absolute value of negative 20, and an absolute value of negative 15, I went from a speed of 20 to a speed of 15, which means I slowed down. So when I look at these four examples, I want to come up with a way to quickly determine whether I am speeding up or slowing down if I know my velocities and acceleration. Well, if you look at my first example, I started out with a positive velocity and I had a positive acceleration. In my second example, I had a positive velocity and a negative acceleration. In my third example, I had a negative velocity to start with and a negative acceleration. Then I had a negative velocity and a positive acceleration. So I had two positives for velocity and acceleration, then a positive and a negative, and then two negatives, and then a negative and a positive. The times when I was speeding up were here and here, two positives and two negatives. And when I was slowing down, I had a positive and a negative, different signs for the two measurements. I hope you see the pattern. Speeding up, velocity and acceleration will have the same sign, and slowing down, velocity and acceleration will have different signs. So those are important pieces of information to remember. Let's go back and take a quick look at our summary table. Velocity is the derivative of position. Acceleration is the derivative of velocity and the second derivative of position. Speeding up, velocity and acceleration have the same sign. Slowing down, velocity and acceleration have different signs. In the next video, we'll go over a few examples.